This episode is sponsored by United Refrigeration and Westermeyer Industries, revolutionizing your HVACR experience. Visit URI.com for all your HVACR needs, offering real-time inventory, personalized pricing, and a nearby stock feature. Access quick pick replacement parts and branch details effortlessly. With 350 plus fully stocked locations across North America, our knowledgeable staff are ready to assist with the solutions you need. Exclusive offer. Use code ARPOD on URI.com to get a $10 gift card when purchasing the Westermeyer oil float, part number W4300-38F. These high-performance floats are not just compatible with their own oil separators, but also available as a crossover model, conveniently stocked at United Refrigeration. That's code ARPOD to claim your $10 gift card. Visit URI.com now.
The Sporlan division of Parker Hannifin Corporation is sponsoring this podcast. Sporlan is the leading manufacturer of HVAC and R components. Using quality materials and craftsmanship, Sporlan maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, Zoom Lock Max Press to Connect, and Zoom Lock Push to Connect refrigerant fittings. If folks want to learn more, what do they do?
You can go to sporlan.com.
I guess that's Jim and John for Sporlan signing off.
We're gonna figure it out. We always do.
Yeah, we can roll with it.
Good evening, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel, and I think it's Kevin Compass, but he sounds like a lady that's been in the casino with a pack of marbles for about 4 days straight, playing the penny slots. How you doing?
Oh, exhausted.
I was gonna say you sound really hoarse.
Yeah, been like talking way more than I want to, and I've been working till 8:30 or 9 o'clock every night.
How's the job going?
It is running 100% functional, running. The only thing left is insulation cladding, which I will not be doing.
Insulation what?
Cladding,
Oh, screw that.
like jacketing.
Yeah.
That's not my cup of tea. But no, it is 100% running, and actually the store is actually running net zero like it was supposed to, meaning they're putting 18 kW back on the grid today.
Come on.
Yep. Yeah, they were putting there's that much solar on top of this building, small building. There's that much solar on top of the building, it was overtaking the rack. And once I get permission, I may post some stuff this rack is the quietest. Those Copeland black compressors, the TC compressors, are the quietest compressors.
You can't even tell they're on.
No, you literally can't hear the subcritical ones.
Wait, so transcritical or subcritical? Because the transcritical. Oh, okay, because the transcritical ones they're quiet as hell.
Yeah, the subcritical ones for the low temp are just super quiet.
Scrolls or piston?
Pistons.
I don't think the subcritical ones look the same as the TC ones. Don't
they look the same.
Like the same amount of bolts and everything. Yeah.
Yeah, but they're on a smaller scale, so there's no vibration whatsoever. I didn't have to delete any frequencies.
Wow.
Which is a first. We didn't have anything.
And what was the manufacturer of the rack? Can you say?
Zero zone. So it was quiet as could be. So this particular rack is using geo-thermal, and I am sold on this now. They're using the gas cooler to do the primary heat rejection, and the geo-thermal is doing secondary heat rejection. So it was 95 a day, and we are running 785 pounds of head pressure.
So it was rejecting that much heat that it was able to actually run subcritical.
We could get 30 degrees of subcooling out of the geo wells. We had 55-degree water coming out. And that was all day. That was at the end of the day, too. So we were pretty much on the verge of transcritical today. And it pushed us completely the other way, running it through there.
Yeah, 95. You said it was 95 outside?
90 to 95-ish.
Yeah, I was going to say you should have been running TC at that point.
It was almost to the point where it got to that for a little bit and then started to cool off. But the geo wells pushed us completely to the other envelope. Installing these is going to be expensive, but it is and it isn't. If you drill them, how many stores have retention ponds next to them? Tons. Like you could do a well in a pond and circulate that water, and it's a huge heat sink. The geo pumps only draw like 2.5 amps. So you're drawing that 2.5 amps through there to save on all that horsepower and all that flash gas. And we were still making, so this does domestic hot water too, which there's no hot water load really, but instantly making hot water temp. And then we were able to still run the heating off of that with its subcritical. We were still really able to run the heating enough to run dehumidification. It worked flawlessly. There's 10 wells here. They got a decent amount of money in there, but like you could even think of like 3 or 5 well store, and you were using that to make these racks not transcritical. You could pretty much keep these out of transcritical the entire year. It is down south. That seems like a no-brainer, especially somewhere where the water table's low.
Okay, so that's what I was going to ask. So you said a pond. So this is actually this is in the ground though. This isn't like
These are wells. Like these are actually like drilled wells. We're like a half mile to a mile from the lake.
Mm-hmm.
So a pond though, like you could do pond geo. Like which they just literally take like PEX tubing and just string it out to the bottom of a pond.
Really?
Yep. You figure that water's 85, maybe 90-ish degrees at the most.
Yeah.
So you're taking air that's 90, rejecting to that, and now you're de-superheating even more and possibly condensing with that geo water. I was super surprised how well it worked.
Well, like you said, you're rejecting that much freaking heat out to everywhere.
Yeah, we didn't saturate it was running full load. It says a 40-ton chiller on it. We were at temp in the store.
40-ton chiller for what?
Glycol.
What's the chiller?
For the air handlers.
Wait, it has a 40-ton chiller that's ran off the CO2 rack. Is that what you're saying?
Yep. So it's CO2 to glycol, and then primary, secondary loop, and then that goes to the actual store.
But then it does have its regular
DX refrigeration.
CO2 for both the medium and low temp. So they're just using the 140-ton for all the comfort cooling then.
Yep. And then all the comfort heating comes off of a heat exchanger. So off a discharge.
Same thing with the dehumidification, I'm assuming, right?
It's all, that would be the heating loop.
The same loop that they're using, just modulating hydronic valves for the control.
Yep. Modulating hydronic valves for the control, and it's a 4-pipe system, so you can run heating and cooling at the same time.
That is pretty badass.
No, it is. This has been a year in the making, and it's been flawless. And the whole thing is it going to be net zero? And so far, from what I could see from the KW monitors, they were almost putting 38 KW back at some point.
Oh, did you figure out the last week you were talking about the flow meters? Did you figure out the flow meters?
Yeah, that was a nightmare.
Yeah, what happened there?
So I finally got a hold of somebody at that company, and they showed me how to zero these. And the whole process, none of them were set up right from day one. Which was part of the issue this thing probably had from day one.
Okay, so based off of like when you set it up, what was it?
They were the wrong pipe sizes were entered and the wrong pipe material.
Oh,
so it's electromagnetic and it's a heater, and it affects how fast it goes through there. If it's got the wrong pipe material, then their calculation's wrong. And same thing for pipe size. They had it set for 2.5 inch. It was calibrated for. It was 3.
What was up with the circuit setter where you had the drop? Was that legitimately wrong?
Yeah, that was undersized.
Okay.
It just had a massive drop from as soon as we got that taken care of and we got the Jeep flow meter right, it was instantly matching with the design flow.
Badass.
So yeah,
No more, you got all the air out?
yeah, that took a week and a half.
Last thing I'm going to ask you about, did you get your pump cycling? Because you've been like apparently working on that for quite a while. Is that all set? All square? Because you had 3 different pumps, right?
There's 15 pumps.
No, but I'm saying for each loop.
Yeah, so that is
Still a work in progress.
so we changed the whole pump sequence today for the geothermal.
Mhm.
So today, when it's in rejection mode, meaning like it's rejecting heat through to the well,
Mhm.
we originally were just going to run it off GPM. And now we're running it off of the T2 sensor on the iPro.
Which is the heat reclaim.
Yes. So actually, it's the gas bypass sensor. So gas cooler bypass sensor.
I was going to ask you how it's supposed to work because I had a question about that today because I saw that Bullseye is starting to put the bypasses on the discharge going into the gas cooler. And I was trying to get sequence of operation of what it's supposed to be essentially doing. Like, when is it supposed to be bypassing?
So usually it's when the way this rack is set up, it's just probably the same, close to the same sequence is when it can't maintain the minimum pressure
Mhm.
in the gas cooler and temp, it
Mhm.
starts to bypass.
Oh,
And it's variable.
oh, okay.
So like this rack is variable. It has a Danfoss 3-way valve in it,
Bipolar stepper or
bipolar
3-way?
stepper.
Okay.
So it actually can vary off a 0 to 10 volt signal how much it opens. Now, the way this is set up is we're driving the geo pump off that T2 sensor. So T1 is on the drop leg at the rack, and then T2 is after the geo heat exchanger. That way, we can take that and we could drive the pump speed off of that. If the T2 sensor starts getting too cold, it slows the pump down. If it
Oh,
starts getting too warm, it speeds the pump up. And then it switches when it's in heat pump mode and we're
Mhm.
taking heat out of the geo, it mixes in a buffer tank and we maintain 41 degrees in the tank.
Gotcha.
So as the temp goes up, it slows the pump down. As the temp goes down, it speeds the pump up. So it's the opposite PID.
Okay, so it's just inverse. I literally just almost ended this podcast.
But yeah, there is, I think the one rack has 57 flexible combiners.
Oh my God. Just got it. Blah, 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 blah. So this is what I was going to show because since we're talking about it right now. Anyway, blah, 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 blah. So if no one, let's zoom too far. There we go. Come on, Jamie, fix it. All right. There's your gas cooler. There's your 3-way valve. And, oh, there's your temperature sensor. That's the one you're working off of. Actually, in yours, you're working off the one off the heat exchanger after, because this would be the geo loop would be after this.
Correct.
Okay. So in essence, this is the same thing, except for you have a geo loop on the drain leg before the 3-way valve. Is that correct?
Yeah, I don't know what they're because that goes right to the high pressure valve, correct?
There's a heat exchanger.
Yep, and that comes out of that, and
Yeah.
then
Out of heat exchanger. HPV. Yep, right there.
yeah, I don't know what they're controlling with that temp sensor. To be honest to you, like how hot they're giving it, because I guess if it's really that low, it's bypassing. I don't buy the whole bypass. I think it's a bad idea. I like the condenser split method.
Yeah.
Because there's just too much to go wrong too fast.
To be seen, right? We haven't been. How long have we been doing it here in the States? Not that long. A lot of these prints just came out for doing this thing. And then, are you using? Because I saw this. Blah blah blah. Is that the controller they're using to control that 3-way
Yep.
valve?
Yep. Those things work great. If you don't have the screen, then you are screwed though.
Why?
because you need that program, like that shows a laptop, you need that adapter to talk to it. But if you don't have that screen, you are screwed.
This gateway thing?
Yeah, you need that gateway, which nobody knows where to get it. And then that MIGRS screen, that's what you need to address it and set it up. Super simple. Give it a 0 to 10 volt signal. You can make it inverse or direct acting, and it just drives the valves.
So yours had this though.
Yeah, no, I have a screen and I have 3 of those valve drivers. Those are all driving different 3-way valves. Those 3-way valves work flawlessly. They're quick. The only problem is I think that they only have them in one size right now.
Gotcha.
So,
so you need this display right here.
Correct. Or else you cannot set those valve drivers up. You could also use those for high pressure valve drivers. It's a great general valve driver.
Oh, look, and it can be CAN bust off of another controller like the pet.
Correct. Like all mine are CAN bus together.
This looks, you know what this looks like? This looks like a Corel. Look at the buttons.
No, you know what that is? That's that one we see in AHR, that one that's supposed to be
fancy new one?
Yeah.
Gotcha.
Yeah, those things work great. The gas cooler bypass is definitely, for like an Aldi, that would be great. Like a Trader Joe's, something small, it'd be great.
Okay, so battery backup, and then here's your valves, and the alarm relay, and then power supply. So this is, see, it's weird because it says superheat controller, but I guess they make different integrations based off the numbers, yeah? All right. And then there's all their settings that they want. But yeah, so this is essentially what we're talking about. It's this 3-way valve here, and that's why we have to have a check valve here. Yeah, because I think this is easy too. This thing here. This is
you'd always tell with their heat exchanger a drop leg.
So one thing I did want to bring up. So like a lot of, and here we go again, just CO2 straight up. So anyway, so you see where it says 650 up here on the relief, and then it says 870 here, and then it has the service, the service T, so you can make it relief on 870 or 650. If you look at these prints, be advised that here, right here, it tells you what the piping dictation is. So you have type L here and type XHP right here, which technically means if you are going to utilize this, that pressure can't be on the other side of this valve or this valve, right? Because you have XHP back here, you have
Correct.
XHP here, and then you're with L here. And so if you were to isolate, let's just say the filter dryers here, and then relief that thing up here, if there would be no relief anywhere around here, you could potentially relief out. Agreed or not?
Say that one more time.
Look, you have XHP here.
Yep.
Okay, 1/8". You have L copper, 1/8". L copper. So you see where the purple changes into the blue. This is where we change there. So if you were to technically, if you had some sort of isolation, like at your liquid header, and you'd close off this valve, and you wouldn't have any reliefs from here on out, and you would switch this relief over to the 870, where now it's only going to relief when it goes up to 870. I'd think that this potentially comes into possibly getting damaged. No, I know, but I'm just saying, if it's L copper, all right.
L copper.
That's what it says right here.
Really?
Yes. Can you not see that?
Usually it's K at the rack, but
no, I understand that, but that's my point. If this is L copper right here, and it could be because it's a lower size. All right. Let me look up something. Let's segue to something, and I'll bring it back to this, because like I said, I don't want, there's a good, like I said, I want to make sure that we're straight up on this, because if you were to shut off the relief at like past the valve, I don't know what the relief pressure is of 1/8" L copper is what I'm getting at.
Sorry, my brain just stopped working for a second. But no, yeah, that I don't know. I'm interested to see how the 3-way bypass valves go. I definitely think it's an improvement on what we have, but I'm a condenser split kind of guy. I think that's going to be even more.
Have you even seen any of them up here in the States yet?
What?
Split.
Yeah.
You have? Where?
Costco's done them.
How do they really?
Yep.
I haven't seen them yet.
And then we did one in a Carnot rack. It's just an automated ball valve, though.
Oh, for the split?
Yeah.
Gotcha.
So that's all it was. Automated ball valve off, check valves, and drop legs. It worked good. And then we just dropped that side of the Gutner off.
Gotcha. Oh, yeah, there we go.
Find it?
I did. I'm just going to zoom this in a little bit. It's on a thing. All right, so that was 1.1/8, right? Oy. Do. Go. All right, let me share this back on there. There we go. So L-type copper at 1.1/8. If it's drawn, working pressure is there at 733.
So we're talking pennies and hand grenades here.
I don't know what you mean.
It's good.
But that's why they relieve it at
Look at the burst pressure.
Yeah, I know that, but we don't want to run.
That's a big difference. Pennies and hand grenades here.
All right, I've never heard that term. Is that an Indiana thing?
Maybe. Yeah, I'm fine with it. What's your thoughts on the anti-relief?
The anti-relief?
Yeah.
You're talking about the relief that goes off before the main relief?
I hate it.
Why?
Because they stick.
All right, so when you say they stick, where are they sticking? You talking about the what are they using for the valve?
I've seen the CDS one and the solenoid one stick.
So one of the stores does both.
I've seen both, and I've seen both stick too.
Really?
Yeah. Because once it gets that dry ice in there, it's done.
No, I understand that, but theoretically, if you have no pressure drop across the solenoid, right? Because if you have no pressure drop across the liquid line solenoid, theoretically, if it still has pressure on the other side, like it shouldn't roll. It shouldn't turn into dry ice. So my question is to you then, how far is that CDS valve open? Are you limiting that at all?
I'm not sure. I think it goes wide open.
No. So my so that's one discussion that I had with someone because they were having the same issue where it was sticking. And so what I told them to do is limit the amount of max opening percentage. Because if you have like
Makes sense.
Because if you have an SDR, I don't know, let's just say you have the bigger one, you have the 9 or whatever the hell it is, right? It's 6386 steps. So that means it takes 32 seconds to fully open up. And usually it only needs to open up a little itty bitty baby bit in order to burp that pressure off. So if you limit the amount of opening percentage and only allow it to open up 5%, you're just trying to burp it just a little bit to bring that pressure down before it rolls. And then you're still keeping the pressure drop across the solenoid, which means if you still have pressure where it's liquid, then you shouldn't technically create dry ice because they're still going to have that pressure above the triple point.
Yeah, no, you're right.
Does that make sense? Am I talking? No, but that's what we did to get around that for the other thing. If no one knows what we're talking about, I'm about to bring up a picture of what that thing looks like. Because
I don't know. I've had more bad luck with the anti-reliefs than good luck.
And that's why they ended up putting the solenoid in there, right? Because let me bring up a picture so they can see it. Because they're going to be like, what the hell are you talking about? It's basically an electronically controlled relief before the main relief lets go, right? So if you could burp the flash tank off just a little bit, maybe you won't have a major relief vent out the actual main relief on the flash tank itself. And so they tried with the CDS valve, and then what was happening is, like Kevin was saying, where on the outlet there, because if it's on the flash tank, it's vapor at the top there, but you have a lot of liquid movement throughout that whole vessel, and so all that's going to just tear off into the relief and then potentially cause dry ice there. So what they started doing was they put liquid line solenoids on they put liquid line solenoids on the pre-relief in order to prevent the thing from totally blowing off. So you had some way to shut it off in case you created dry ice in the actual CDS valve.
So now there's all this talk about 90 bar. So I know that NSARC had some big thing like trying to push people to 90 bar. It's
not that they're trying to push it. It's everyone that's on those meetings or whatever. They're just trying to figure out a way because now they're seeing, before, where were we relieving? We were relieving out of leaks, out of things, right? Now, every time you hear a relief, it's from a relief event. And I argued a little bit it's training, right? Some of it's training because you have, if they're not up to how the controls work, or they have a misunderstanding on how the controls work, they're going to cause issues where they have reliefs. And so they're thinking that, oh hell, just put the pressure all the way up to be able to withstand the ambient of the actual of where the system lies, right?
Today's episode is sponsored by the RefraShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales at westermeyerin.com. That's WESTERMEYERIN.com.
That's great. I like it. The only problem is it's super expensive.
Yeah, and the cases, right? The cases
the evaporator coils is what's going to kill. And then the pipe. So the pipe is triple.
Yeah.
And not so much, it's hard to get, but like the big pipe, like
you went all robot on us for a second.
Oh. No, I don't know. The whole 90 bar thing, like I would think I'm a big fan of the backup units.
Oh, agreed. So this is a shot of a bullseye one. So you can see, so here's your ball valve coming off your flash tank. There's your solenoid, and there's your SDR valve. And then it relieves outside. So if, like, this is what I was explaining before, this is a huge valve. And so if this valve is roaring at like I said, 6386 steps, that thing's going to open up 100%. It's going to take a long time. So by the time it says, oh, I reacted, and it's already halfway there, it's going to take another additional X amount of seconds to get back. So if you were to just limit the opening percentage up to, let's just say 15%, you at least would keep a pressure on this side of the pipe before it's able to relieve. And then essentially you would have way less likely, of a chance of basically creating dry ice.
Yeah, I've seen it stick less, but I still have seen it stick. But have you seen this has been a big problem, the rack houses on the roof, the relief lines blowing out like at a 90-degree angle? Because they want you to vent them over the top, and there's nothing to attach it to.
They're not supported.
Yeah, even if you support them, there's like nothing on the rack house to attach it to. Because it's all sheet metal.
Yeah. So this is the other thing that they're thinking about going to.
Best idea ever.
And so this, if anyone doesn't know, this is an auxiliary unit. A little mock-up on an auxiliary unit, right? Shut up, don't laugh. So anyway, so you have a condensing unit, and typically it's made for both when you have a rack failure, but also when you have a power outage. The only caveat to that is, as Kevin would say, is that this guy right here would have to be on a generator. They use a mechanical pressure switch hooked up to the CO2 side. And it depends on the piping or whatever. On this one, they're suggesting that you cut in at 39 bar and have a 4-bar differential for it to cut in and out. And I forget what refrigerant. I think they were using 449 for this. Maybe.
Yeah, that's
maybe.
usually what I see.
So 38 or 23 PSI cut in and 15 cut out. So they're basically just shutting this thing off and on, just trying to maintain this.
My thing about this is what makes it great is even if you come into a high load, this can kick on and help you bring down that flash tank.
Yeah. Yeah. But if someone takes advantage of that, like if there's an issue with something and they really don't know, and they're like, yeah, I'm just going to play around with this in order to get it rolling. You know what I mean? They're using this as a Band-Aid patch just to get through. That's the only thing I don't really dig. You know what I mean?
So if I'm doing a brand new rack and I'm stacking CO2 in it for it to run, and I have the backup units running, I will put several 100 pounds of liquid in the rack with the backup unit.
Yeah.
Because you just let it run, let it drop the receiver as low as possible, and you just keep on charging.
By the way, this is a really, I needed a condensing unit that actually visualized. This is a huge freaking unit. You wouldn't see one this big. On some of the transcritical racks, they're fractional horsepower compressors. They're not that big at all. It's just made just to turn that vapor into a liquid and bring the pressure down. And that's why typically these units now are mounted on a lot of the units right above, because the heat exchanger actually needs to be above the flash tank, because then you have this thermal siphon effect. So the vapor rises up in the top, gets condensed, drops down the bottom, becomes liquid, and the cycle is repeated just to bring that pressure and temperature down.
So we were talking about this, the geo rack we have.
Okay.
Technically, say you have that geo rack and you're 45 to 50 degrees on the geo.
Mm-hmm.
You could basically make that a thermal siphon.
Yeah. Yeah, absolutely.
You could basically use that and run the glycol through it and cause it to condense and keep from blowing reliefs.
Yeah, no, absolutely. But once again, or use it as a supplemental in case you have, hey, I'm waiting 8 weeks for this really expensive German fan, and I need to get this thing rolling. Because I saw someone posted on Facebook, I got a fan out. It's a 22-month lead time. Can I just get a fan and just put it on top? And I'm like, weatherproof.
Somebody needs to make a retrofit kit for those motors.
Oh, yeah. Where you can just put a regular run-of-the-mill, regular bladed fan on.
Yeah. I don't know why all these gas coolers are coming out with these. Why can't we just get a gas cooler?
Because you have the available, and I know because you can Modbus them together without having extra controls to shut off contactors.
So, yeah, that's fine, but you could do that with normal motors.
Yeah, I know. So here, check this out. Oops, sorry.
I actually just started up my first Heatcraft gas cooler.
Mm-hmm.
And
it finally came out. Yeah.
It was nice, but it had the ECM motors in it instead of I was hoping it was going to have those next gen motors. Those things kick ass.
Those are the ones on the keep rate stuff?
No, the Heatcraft, the US motor ones, they're variable speed ECM motors. They look like a normal motor. It's the same motor bracket. But the thing I like about those is you could drop a normal motor in its place if you need to.
I gotcha. But yeah, so I was the reason why I was doing the math is because I was trying to figure out what the cut in cut out. So 507 cut out, and then because I have a bad memory, 39 times 14.5.
Look at you all fancy converting bar.
I teach my guys to do that because a lot of these controllers are still in bar.
Nobody does that. They just look on Google and type it in the calculator. That's what I do. I am way too lazy to do that.
You want to hear something screwed up? Like how I can remember certain things. I swear to God, yesterday I was making the schedule for training. I couldn't remember when Thanksgiving was. I had to Google when Thanksgiving was.
Oh, it's the best day to be on call.
No, I understand that, but all I'm saying is I couldn't remember that. I can never remember Labor Day and Memorial Day. But what I mean is I can't remember when those dates are. Like I can't remember. I don't remember holidays all that well. But anyway.
Yeah, so 565. That sounds about right.
Yeah, because it's right before the relief. The first relief is typically 6:35 or some stuff.
Yeah. You'll have that. You'll
have that on the big jobs.
Oh yeah, I've had a lot of high pressure valve issues lately, and this is the first go around where I've blown reliefs. Like
what?
Yeah, like not this store we just did, but like the last store, nonstop high pressure valve issues. Like it would drive, then not drive, then not drive.
Oh, okay. All right, that was different. I thought you meant you like. Okay, never mind.
What?
I don't know. I remember. I knew you had issues on the last job you had, but I know. We saw the bush fix, as you would typically refer to it,
or the pile of parts, like the giant pile of parts. Yeah, that was bad. Lots of burned up motors.
Hey, Justin, if you're listening, ship those parts back to me, by the way. My buddy Justin had a whole bunch of stuff that he was going to ship back to me, and he never did yet. Jerk. What are your feelings on the motors that they use for the Ref Plus units? Because they use the main variable speed ones for the primary two fans, but then for the other ones they use the 2-stage. What do you feel about that?
I don't like that. I'd rather them all just be ECM at that point.
Yeah.
So I have a Ref Plus in that store that I just started up.
Which one?
The store, I can't say the name where it is. I actually lost the first gas cooler fan motor already.
What?
Yeah.
Did you break it?
No. It just won't do anything. So we had to change one of those. I just don't like how heavy they are and how like cumbersome they are to get on a roof.
But all those big freaking huge ones are. They're all cumbersome.
I do like how easy the Reef Plus was to split up the motors. They already had the wires in there to do it.
Mm-hmm.
So all I had to do was add relay logic in, and I was able to split the motors up. Because I am diehard against this. Running all the motors at the same exact speed all the time is the dumbest possible thing you could ever do. You need individual fan control. You need fan cycling. There has to be fan cycling on these CO2 racks. Maybe not in Texas, but.
Was yours a dry gas cooler?
Yeah, dry.
You want to see something really crazy? You know what? Josh, Ref Plus, if you're listening, you need to get your ass on here because we need to talk about this. So they have. They have
this retrofit kit?
No, it's not a retrofit kit. It's what they're doing is it's an adiabatic, but what they do is they coat the coils with something. I don't remember. He told me, but I don't remember. But instead of spraying it on pads, because the pads usually end up deefing after quite a minute, they have a filtration system that's on this thing. And what it's doing is it sprays the water out, but it doesn't actually wet. Doesn't actually wet the coils itself because it atomizes the water so fine that by the time it actually gets it's just really just cooling down the air when it's sucking it back in, because you see how they're blowing it away from the gas cooler itself. The only stipulation with this, when you put one in, because I was like, what happens if you put one of these in? He's like, you need to buy the filtration thing, because otherwise it wouldn't probably go well, because we all know how a lot of people don't do the proper water filtration, right?
It would almost be like, I would be worried it's almost like a non-hillbilly sprinkler.
Yeah, essentially, except for the fact that they coat the coils. And here, look, right here. There it is. This is the filtration system that actually make you purchase with this thing.
So it probably somehow softens the water a little bit.
I don't remember if it's RO. So you have, I see water filter.
Wouldn't RO up copper?
See, I don't know. I don't. That's why I didn't want to say RO. No, okay. So UV light filter. But yeah, so they make you filter, and then what they do is I believe there's a solenoid down there in the bottom, and then essentially what it does is it drains out the water when it gets X cold.
It's super interesting. I like the Replus stuff. I think their coils are great.
Oh yeah.
Except I will say this, the wiring diagram and the one we were doing in this freezer, I was like looking at them like, what the hell is this? It looked like it was 3-phase, but not really. I'm like looking at it because usually you got all 3 legs of power, like or 2 legs of power right next to her, L1, L2. So it had L1, L2, and then it had L3, but coming off the motor like 4 inches less than the other ones.
Oh, so just stop but not hooked up to anything?
Yeah, like it didn't like it was on the diagram, but it was laying on the terminal block. So like it looked, I'm like sitting there looking at it, and the tag wasn't clear. So it was super confusing.
You're talking on the actual evaporator?
Yeah.
Okay.
And then I'm like sitting there, I'm like, why do we have a 3-phase 1/20th horsepower motor? That seems pointless.
Are those 2-speed motors on that or no?
No, singles.
Really? Good.
Yeah.
I
am not sold on the 2-speed motor shit.
No, because half the time they don't get
doesn't work
properly.
And it doesn't work for like a grocery store. It just doesn't. Like we're always running refrigeration, except we're in defrost.
And so did we ever get anyone to answer that question?
What's that?
Because
defrost?
Yeah, like why would you even dumb it down or speed it down like during defrost? Because to think like you'd be moving less air across, so you would need more defrost. No, unless maybe I'm wrong.
No, you're definitely not. It definitely takes longer.
Okay.
Like this is the other thing I wanted to bring up. I got a full-on argument at a store about defrost times.
Wait a minute. You got into an argument?
Yeah. I had the full-on like argument with, of course, the EMS company about we're starting up a bunch of Husband cases, the like C5 or the ID cases where they get
the booby high ones, the ID5s or the
BS 20-minute defrost.
We talked to Dale about that. We resolved that issue with Sizemore when he was on here.
Yeah. Okay. You can't use the 20-minute defrost, and it requires a plus 28 coil, and you're running a plus 22 CO2 coil or CO2 saturation with no EPR. That does not work. It's going to ice up.
Agreed.
It needs 30 to 35 minutes.
Agreed.
Like all these Sam's Club where these are going in, they're all icing up everywhere. It is insane. Like these manufacturers need to update these specs to like a realistic thing.
I should talk to that guy. So when I was teaching out with Rusty at NASRC, when I was teaching about like case controllers and stuff like that, and I said, yeah, like everyone has like the fan spec except for, and I laid off Husband. I didn't know they were in the room, and the guy came barreling down at me later. He's like, you know what, Brett, you're absolutely right. He's like, we're gonna actually start putting that in the spec, so you actually can diagnose like how fast the air is in fact supposed to be, so you can actually diagnose it. Because unless you're just like one of these things is not like the other, measure like one over here and then measure another one over here to actually get the airflow, see if it's right, because they don't label it in their manuals, right? And so maybe that's what they should start doing. So like just how they have sizing in the for the evaporators, right?
For conventional and DX.
Yeah. And maybe they should start actually doing, okay, so if you are at still, I'm not saying change the humidity, keep the humidity the same, but all I'm saying
change the SST.
Yeah. So because they're having it in a freaking lab. Okay. Let's run it at the 28-degree coil. All right. Yes. 20 minutes. Okay. But then if you decrease that by 5 degrees, you have to increase defrost time by 5 or 10 minutes, like whatever it might be in the lab.
Can we make it realistic and make it a little bit humid? Because let's be honest, grocery stores are not labs, and I don't care what anybody says, it's never the perfect conditions.
Oh, I got something. If you're done talking about that, I got one last thing to bring up because this was awesome. You ready?
Yeah.
Ready? All right. So I was talking to someone down south, and they had an issue with I think it was just Cascade rack, and it was at a certain store, and you're running on the Cascade rack. I think you're running 206 pounds or 200 pounds for your suction for your CO2. And He's like, Brett, I think I'm low on CO2. I'm like, what do we shut off some cases? He's like, it'll work the same. I said, yeah, it's a DX refrigerant. Just shut off some cases and see if you can get it flowing over. So he shuts it off. No difference. He shut off 2 or 3 different cases. And I called him back later because he never called me back. And I was like, what's the deal? He's like, yeah, it didn't work. But then when I opened up the ball valves for the cases, that case dropped down dramatically in temp. I'm like, that's really weird. So I logged in the store and you could see what happened. So when he opened up the cases, because he had them off so long, the pressure in the pipe went all the way up to 260 pounds. When that happened, you were running a higher saturated. So then the case superheat was running at 50 degrees. It went all the way down to nearly set point. And I was like, that doesn't make any sense except for if it's sized differently. So he's like, yeah, these 2 cases are running medium temp. So they were running at a 34 degree temperature set point. And the other cases on the same suction were at the 0 or negative 10 degree, whatever the set point was. So I was like, maybe they're undersized. He's like, how do you figure? They've been working forever. I was like, when did they put these in medium temp? He's like, apparently they've been there the whole time, but they've always struggled. And so that's what it was. We did it again. We tried to shut it off. Like when I have a problem with this on a regular chemical refrigerant rack, 448, 449, I'll shut off the ball valve and use the ball valve is almost like an EPR. And he did this on the CO2, but it was an internally check valved ball valve. So the pressure
screws you a little bit.
Yeah, it did. The pressure went up, I think 25 or 35 pounds. I don't know what the Sporlan spec is, but it went up that many pounds or whatever. But I was like, you know what? Screw it. I said, open up the ball valve back in. Let's try it one more time. Because if it happens once, maybe it was just a fluke and some shit happened. Let's try it again. So we did it again. Once again, the pressure rose up and it did the same thing. Superheat came back down to where it needed to be. And I was like, that valve is undersized. Chances are that when they bought that case, they assumed that case was going to be running in low temp. And so he's like, what do I do? I said, do you have the rebuild kit? He's like, I don't, but I got a drill index. So that's what he ended up doing. He took it out. I was like, how did you figure out what size? I'm like, he's like 1/16 sounded real good to me. So he drilled it out. Not that I agree with that entirely. Cause I was like, it's a happy medium, right? Like you need to have the customer make the decision. Is this definitely going to be a low or medium temp case forever? Or is it going to be a medium temp case? Because based off of that, you need to make an educated decision. Do I go X amount of size is too big because you didn't want it too big because it was only 500 BTUs per door and it was a 4-door unit. We've talked about this before. Every time you drop the saturated, typically double than what the TD is. So a lot of these cases now have a 6-degree TD for the frozen. So he was running, I don't know, negative 20 to 40 degrees in the case or 30 degrees in the case. So he was running ridiculously high TD. So the coil was acting as oversized. So he just needed a bigger orifice. So like I said, he drilled it out and she took off running.
It's gonna become more prevalent. Remember when I had that at that Schmamajan with the dairy coolers?
Yes.
That it wouldn't make temp, and arguing with them, and they shut the ball valve, and it just rockets down to temp.
And that's what you did, right? We talked about it, and I was like, close off the ball valve and make it act like an EPR, right? Because that's all you're doing.
Just shot down to temp.
Yeah, because you did all the calculations. You were like, man, if it was running the right suction, it'd be running straight up. What did you end up doing? Just you didn't use a drill, right? You just put in a bigger valve.
Later on, they went back and put EPRs in the entire store. The store didn't open for 2 years.
What?
It literally said, so like those buildings, I'm going to one tomorrow. This building has been sitting for 2.5 years.
Why?
It just takes them that long to open a store. Super weird.
Fun time.
Yep. Guys, call it a night and thanks for listening.
All right. See you guys later.